Hey everybody, it's Derek Martin from CodeOpinion.com. When should you choose blocking synchronous communication or non-blocking asynchronous communication? Should commands just all be fire and forget? And what's really the big deal of making RPC calls between services? I'm going to tackle a bunch of different situations and explain the reasoning behind each. I'd like to thank Solace for sponsoring this video. Solace provides a complete event streaming and management platform that makes it easier to design, deploy, and manage event-driven architecture across hybrid, multi-cloud, and IoT environments. For more on Solace, check out the link in the description. So there's generally three forms of communication that I'm thinking of: commands, queries, and events. So I'm going to cover each one of these and specifically kind of the trade-offs and the pros and cons of using synchronous or asynchronous, blocking, non-blocking for each of these. So for synchronous commands, a lot of this comes down to latency and the expectation of the user that the command that they're performing is going to be fully complete when they get it back. So that means that a client makes a request, some type of command to our service. Let's say it's just making a state change. So we make that state change and then we return back to our client saying, yes, great, everything is completed. Now, a lot of this is to do with the work involved in the latency. If it's going to be short just because you're making some type of simple state change, then there is really no issue of it being synchronous. Where this becomes more of an issue is if it's going to take a long time to perform that work. And that's an issue because it's a blocking call. When our client makes that call to the service, and let's say it has to perform a lot of queries, a lot of different writes, it's doing some big type of long process that's going to take quite a while, we're blocking our client. Our client is sitting there waiting. So if we're going to have high latency, rather we can move at this point to something asynchronous, where we can make that call from our client to our service, and our service at that point, instead of actually doing the work, you can just create a message that's going to put on the queue. And once it does that, we can then go back to the client saying, we've completed accepting your request. We haven't actually fully processed it yet. And again, there has to be some indication to the client that that's actually what happened. It wasn't actually completed. From there, our service asynchronously via another thread, a separate process, again, this is about kind of this logical boundary of the service, can pick up that message from the queue and then actually perform the work that needs to be done. But the key is we weren't making the client wait. We weren't blocking them. We accepted their request. We put a message on the queue. We immediately returned to them saying, thanks, we got your request. We will process it later. And then we do that asynchronously. We weren't blocking them. So a good example of this is I'm in the AWS EC2 console, and it's when I'm going to actually start one of these EC2 instances. If this were just a pure blocking call request, I'd have to sit there and wait a minute or however long it takes to actually start an instance. No, rather, it's not a blocking call. It's not synchronous. That initial call is synchronous to their server, but then from there, it's likely behind the scenes creating a message for work to be done asynchronously. So when I go to instance state and I go to start this instance, it says, okay, I've successfully started. It's not started. It's not completely active and ready. I have to refresh. Now I can see it's pending, and then eventually it will be successfully started. But my UI isn't locked up where I can't do anything else. No, I've sent a message. I've enqueued the message. The rest of the work is happening asynchronously. Now, when you move to something asynchronous, how do you tell the client when that asynchronous work is actually completed so that the UI updates and the user actually knows? I'll have a link in the description where I kind of cover this topic using things like event-driven architecture and WebSockets. Now let's talk about queries. Queries are naturally going to be synchronous, blocking request response. That's kind of the whole point, is that you're requesting data. You want to get data back. So just as you would think of it, you have a client that requests data from a service. That service has to reach out to its database, cache, whatever resources, infrastructure it has, and block while it's getting that data so that it can return it to the client. Naturally, in most cases, the client is going to make a synchronous call, and it's going to be a blocking call to a service. Now, where this falls apart is when you start thinking of a client not as being kind of the end or the originator, but rather starting to think about service-to-service communication. And that's where this falls apart in a hurry for multiple different reasons. One of them I'm illustrating here is latency and kind of visibility to knowing what other services are doing. So if you have a client that makes a call to service A, and it then needs to reach out to its database to get some data, and then it then needs to reach out to service B, and service B needs to hit its database, then service B actually hits service C, and it reaches out to its database, and guess what? Service C is now on service D, and it has to get data, and that goes all the way back up the stack. Nope, we're not done yet. We also have service A that needs to call service C, which it reaches out to its database. And for some reason, we have this tangled web of lies here where service C need to call service D, and we go all the way back up the stack. And that was all blocking till we finally return to the client. Making all these different network hops from service to service to service without any visibility when you're making a call from, say, just you're working on service A, and you just think you're just making a routine call to service B, you really don't know what's going on behind the scenes if it's just a free-for-all where any service can call any service. But it's not just latency, it's also failures. And because you have really no concept of what services are calling other services, this can get really out of hand. And how do you deal with these failures? So what I'm describing can apply to queries, but I'm also going to use it in the context of a command. So let's say that we have a client that's making some type of request to service A, and it needs to make some state change or get some data. It then calls service B, and we keep going down this path here. What happens if for some reason we get to the very end and we need to call service D and this fails? Now service C needs to have some resilience on service D and so forth all the way up. But if we were performing some type of state changes, we don't have any type of distributed transaction. So all the stuff we did potentially prior when service A called service B to make some state change, how do we roll that back now? My answer to this is don't get yourself into this mess in the first place, specifically when we're talking about long-running business processes or workflows that involve multiple different services. I'll have a link in the description where I talk about orchestration and a way to manage this. So on the query side, probably the most common question is if all these services aren't communicating with each other, how do we kind of build out some UI? We want to do some type of UI and view composition. So probably the most common way of doing this is with a BFF, and that's a backend for front end. So it's going to be sitting in front of all our services, and that's what our client's going to communicate with. So it makes that, again, a synchronous request blocking call to our BFF, and it's the one going to reach out to all the different services. It could be concurrently, and they're going to return all the relevant data for whatever the request was. And our BFF is the one going to do that composition and then return back to our blocking call to our client so it can build out its UI. Now, yes, our BFF still needs to think about kind of failures and latency between these calls between all these different services, but it's very, very different because it knows when it calls any individual service, that service isn't calling another service, like my example before. We don't have to worry about kind of this tangled web of what services are calling what services. We know when we're calling from our BFF to any individual service, yes, it may be interacting with its boundary and making some network calls to its database or cache or whatever those services are, but we're not in kind of a tangled web here like we were before. Now I'm going to throw a wrench in the mix and talk about blocking request response, request reply, but using messaging in a queue. I think this actually has kind of one good use case that I'll get to at the end. But first, let me explain how this works. So our client makes a request to our service, and from there, our service actually maybe creates a message and actually puts that onto the queue. But it's not like before where we're immediately going to return back to our client. It's still blocking. We're still blocking at this point, but we're doing now work completely separate, say via another service. So we have another service that's going to pick up that message and actually perform the work that needs to be done. Once it completes that work, it's actually going to create a reply message and then send that to a completely different queue. So from there, our original service that's still blocking our client, it will then go pick up that message and realize, okay, now we're complete, and then it can return back to the client. So the big issue with using this blocking request response with queues is actually the queues and the latency that they can introduce. We have no idea when we enqueue that message how many messages are actually in the queue and how long it's actually going to take to process and be consumed by that other service, meaning we have no idea how long it's going to take to get a reply. If we kind of have a happy path and everything's working great and we have high throughput, then yes, this is going to work great. But the moment that anything starts getting delayed, our blocking call there from our service is just sitting there blocking, waiting for a reply. Now, I do think request response using queues can be helpful, but asynchronously. I'll have a link in the description for a video I've done on that related to workflows. Now, this request response using queues that's blocking, though, I do think has one good use case. And that is when you're kind of transitioning to messaging. So if you already have an existing application where you have, for example, a controller where a client makes obviously a synchronous request to that, and it needs to respond with the result. But you've now started developing a new portion of this that is asynchronous, that's using queues and messaging. This can kind of fill the gap and bridge the gap so that you can still have your existing kind of controller or route in place, but be leveraging the new code that you're building. So I think this can be used as a transition, meaning I think you eventually remove it, but I think it's good for transitioning when you are moving to messaging. So finally, let's talk about events. Now this may seem obvious or maybe not. So we have our client, we have service, and we have different consumers. Now, if we're talking about this being synchronous, if we perform some type of state change, we need to publish an event, and we make synchronous calls to our consumers. Maybe this is in process, or maybe this is an HTTP call to another service, some external service. We made that one call, we need to call another, and then this fails. Well, we kind of go back to this issue of failures and latency. Because it's a blocking call, we're going to be adding latency to that initial call from the client. But in terms of failures, what do we do now? We made a call to that first consumer, it consumed that event, and it's done something. It's actually provided some type of state change, maybe it has some type of side effect. But the second consumer failed. Now we need to deal with that from our service. What do we do? I would rather much have each consumer execute and handle that event in isolation. If we're talking about something in process, as an example, if you're in .NET, this is exactly how Mediator works when you deal with notifications and publish notifications, is that each handler is going to consume that message and do whatever it needs to do. But if there's a failure, you need to deal with that where you actually published it, and it's blocking. So I would rather much be in an asynchronous way using a message broker to publish that message. So that means that we have our client, we do whatever we need to do, we're going to generate an event, we publish that to the broker, and then we're done. We can tell the client, great, thanks for whatever you requested. Now from there, our service, it does not care who the consumer is. It doesn't even know that necessarily that there's consumers. There could be 1, 2, and each one of those consumers is going to handle that message in isolation. If one message can't be processed by one of the consumers and it fails, that doesn't affect the other, nor does it affect that original request from our client to our service. So again, I'd much prefer always having events be dealt with asynchronously in isolation. If you want to get access to a private Discord server where you can talk with other developers about software architecture and design, get access to any of the source code that I show in any of my videos, check out the links in the description on how to join. Hopefully all these examples give you a better idea about where you should use blocking synchronous communication and non-blocking asynchronous communication. If you enjoyed this video, please give it a thumbs up. If you have any thoughts or questions, make sure to leave a comment, and please subscribe for more videos on software architecture and design. Thanks.